In this project, we've been learning to program Python, and we started by thinking about the three programming constructs involved with coding. Those are sequence, selection, and iteration. In your lesson so far, you've looked at sequence, been able to get your program to follow an instruction after an instruction after an instruction, one at a time in a logical order. You've also looked at selection, where we can use if and else statements to get our code to make decisions and to follow different bits of code and different instructions based on those decisions. In today's lesson, we're going to look at the third of these programming constructs called iteration. Iteration simply means to repeat a set of instructions, to do something again. Let's think about a game of whack-a-mole. When you play the game, a mole appears out of one of the holes. You have to hit it as quickly as you can. If you hit it, your score increases and another mole appears. If you're able to hit this other mole, your score increases and a third mole appears. If you're able to hit that mole, your score increases and a fourth mole appears. So iteration allows us to simplify the design of an algorithm by stating that certain steps will repeat until it's told otherwise. Using iteration makes designing algorithms much more quicker and much simpler, because we don't need to include lots of unnecessary steps in our code. So let's think of some examples where we use iteration in real life. One example is cleaning your teeth every morning. When you go into the bathroom, you get your toothpaste and your toothbrush, you put the toothpaste onto the toothbrush. You then start cleaning the first tooth in your mouth, maybe the top right tooth. You then move on and you use the toothbrush to clean the second tooth, then the third, and then the fourth, and so on until you've cleaned all of the teeth in your mouth. This is iteration. You keep repeating the step of cleaning a tooth until all of them have been cleaned. So in our brushing our teeth example, our instructions actually started to get a little bit complicated. I showed you on the screen a repeated step of brushing a tooth up until you'd done 10 teeth. An average adult has 32 teeth, so we would need to repeat that step 32 times. Now I don't want to write that instruction out 32 times. There must be a simpler way of doing it. One way we could write it out a bit differently is like this. We could have an instruction to put the toothpaste onto the brush, and then we could tell our algorithm to repeat step 3 for each tooth. And step 3 is to use the toothbrush to clean the tooth. Once we've done that instruction, we move on to the next tooth, clean that one. Move on to the next tooth, clean that one. So I could show my algorithm for cleaning my teeth in a flow chart just like the one on the right hand side. Let's go through it and look at how it works in a little bit of detail. So the first thing I do is put the toothpaste onto my toothbrush. Then I need to do a quick check and make a decision. Have all of my teeth been cleaned? This is just like in selection that we looked at in the previous lesson. The answer to this question, have all my teeth been cleaned, is either yes or no. In effect, what we're doing in our code is creating what's called a while loop. And we're saying while all the teeth cleaned is no, then there's going to be some steps to repeat. So here we are for the first iteration of this loop. I've put the toothpaste onto the toothbrush. I've asked the question, have all my teeth been cleaned? And I know the answer to that is no. So I go into the first set of steps that I need to repeat. I clean the tooth and then I move on to the next tooth, at which point my algorithm goes back to the little decision and question, have all the teeth been cleaned? And I check to see if the answer is yes or no again. My algorithm will keep iterating and repeating through the clean the tooth and move to the next tooth until the answer to the decision is yes, at which point my algorithm can finish, so I take the other route through, now highlighted in red, to the end of the algorithm. This new cleaning your teeth algorithm will work just fine, but there is one problem. How do you know when you need to stop brushing your teeth? Well, for us the answer is simple. We stop brushing our teeth when we've brushed all of them and they're all clean. But an algorithm by itself isn't going to know when all the teeth have been brushed. We need to put something else in it so it knows how many times it actually needs to repeat and keep brushing the teeth. What we do is we need to create a counter in the algorithm code that will count how many teeth we have actually cleaned. So here's the new version of my algorithm with a counter included. Let's go through it and think about how it works in detail first. So the first thing I've done is created my counter in my code. The counter is called tooth count and I've set it to be 32. In effect, this is a variable in my code, and we looked at variables a few lessons back and explored how they're used to store bits of data that we can use and change within the code. Once I've created my counter called tooth count and I've set it to the value 32, I can now start the check to see if I need to do my iteration. In effect, what I'm telling my algorithm to do is while the tooth count is greater than or equal to 0, there's going to be some code and instructions that need to be repeated. So here I am at the first iteration of my code. My tooth count is set to 32 and I check while the tooth count is greater than or equal to 0, follow the steps in the yes bit. So I have to clean a tooth, I then move to the next tooth, and then the third box says tooth count equals tooth count minus 1. All that means is I take 1 off my tooth count variable. So rather than having 32 stored in there at the moment, it's now going to go down to 31, and the blue arrow on the left hand side shows that I go back to the start of the iteration and I check again to see what number I've got stored in my tooth count variable. So as we can see, I've finished my first iteration and I've cleaned my first tooth. I've changed the tooth count variable by 1, so tooth count now is 31, and I'm ready to check again while tooth count is greater than or equal to 0. The answer to that is still true, and so it's going to go through and do the next iteration of my code. So I keep working through my algorithm and going through the iterations, and at the end of each iteration I take 1 off my tooth count. At the start of the next iteration, it checks to see if the tooth count is greater than or equal to 0. Eventually, I'm going to get to the point where the tooth count is 0. That's the last tooth that I need to be able to clean, so that's my last go through the iteration. And once I've gone through that iteration, the tooth count now is going to change to minus 1. At this point, when it checks to see if the tooth count is greater than or equal to 0, the answer to that question is going to be no, and so the algorithm will just end. I've finished the process of brushing my teeth. So here's a really simple algorithm using an iteration, which I'm showing you in Scratch on the left hand side, as a flowchart in the middle, and as Python on the right hand side. This algorithm is slightly different to the previous example, which used a while loop. This one uses a for loop. This means it starts counting at 0 and counts up until it reaches the maximum number of times you want to repeat the code. Let's have a look at it and work out what it's doing. If we look at the Scratch blocks first of all, the iteration is set to repeat 10 times. And each time it goes through the iteration, it's going to print the words "Hello World" on the screen. On the flowcharts, I've created a counter called X and I've set it to be equal to 1. This is the start of my counting for my iteration. I've then got my check while X is less than or equal to 10. Output the words "Hello World." It will then go through, print the text on the screen, increase X by 1, and then recheck to see if it needs to repeat the loop. Once the loop has counted up to 10, it will then finish going through the iterations and it will go straight to the end and the algorithm will finish. Now that we're looking at the Python code for doing our iterations, there's a couple of things we need to make sure we take note of. Otherwise, we could get some errors in our code. The first thing in this code is the word "for" begins the iteration. At the end of my line that says "for x equals 1 to 10", there's a colon. Make sure that gets included. The next line that's going to be iterated, the print open bracket quote marks "hello world" quote marks close bracket, is indented. Python will automatically put that indent in for you, but some people are tempted to delete it out. If you delete the indent out, you'll get an error in your code. So make sure you've got the colon at the end and the indent as well. Here's an example bit of Python code for our loop for printing on the screen then. But as you can see, there's some bits of it missing. You need to decide which commands need to go where in the code. And the missing bits are down in the yellow box at the bottom of the screen for you to decide where they need to be used. Might be a good idea just to pause the video now, work out your answer to this, and then start playing it again to see a model answer.